Let's look about a 1-bit counter, and we're going to use it as an alternating relay. So we've got two pumps, and we want to alternate in between them to fill a tank up. Okay. So we have a relay here, and when this relay is de-energized, this contact will be closed, and pump 1 will be ready to run. When this is energized, this contact opens, this closes, and pump 2 will be ready to run, depending on where the float's at. So to do that, we're going to use a 1-bit counter, and to make the 1-bit counter, we just use a traditional D-type flip-flop circuit here. And the only difference is we take the output here and we tie that back up to the data line. Okay, and that way when we put a clock impulse in, this output will change from a 0 to a 1. It'll just count to 1, 0, 1, 0, 1, 0, 1 with every clock input. This is a inverter here. I'm using a Schmitt trigger, but you can use a74CH04 inverter, a NOT gate, but I just happen to have a Schmitt trigger. I'm using that. We need a steady pulse here, though, so we're going to use a one-shot. We're going to use a monostable NOR gate. Okay. So what we have is these two gates here. They're it's a 74CH02. Okay, it's a NOR gate. So what happens here is we have voltage up here. This is our positive up here. So we have positive on this side of the gate. That means this side is going to be low. Okay, it inverts it. So this is high. This side's going to be low. This side here happens to be low. This is off. This side's going to be high. So now we've got voltage on both sides of the capacitor here. The same voltage across the capacitor. When we close this is going to be high, this is going to go low, it's going to discharge the capacitor. When that happens, this is going to go low. When this goes low, this goes high, and it puts our pulse in. That pulse will last until this capacitor charges back up through this resistor here. This will be our RC time constant here. So when we close the switch here, we're going to put one pulse into the clock, changing the relay here. So that's how it's going to work. I made up a little unit here. We'll see if it actually works. We've got the unit on right now. We're on. We're off. We're on. We're off. There's a time delay in this, so we have to go fairly slow. So that seems like it's going to work all right. Now, this is fun to figure out, but probably want to use just a commercial alternating relay, and these are fairly cheap, and might be better off just using a commercial relay if you're going to do any work with that. So anyway, it's just fun to look at the logic, and thank you.